Okay, tengok balik yang exercise. Okay, this exercise dia combine dengan gas pressure. This one all syllabus combine gas pressure and atmospheric pressure. Okay, number 1. I already put this on in your GC. Okay, number 1, a student wrote several statements to explain the gas pressure. Okay, however, they were in the wrong order. Rearrange the statement in sequence. Okay, this statement about the kinetic theory. Kinetic theory of matter. Kinetic theory of matter for particles, for atom, for particles. So which one is the first sequence? Kinetic theory. You have learned state of matter in Form 3, Form 1, Form 2, the arrangement of particle in solid, liquid, gas. So when it comes to pressure, okay, to produce the pressure, the particle must move. So the first statement that we want to relate with the gas particle is what? Kinetic theory of particle, kinetic theory of gas. Number 1, which one? First box, second box. Mana ni tak ada respon ni pagi-pagi ni. Okay, second good, Mishraf. Second. Okay, you must know that the gas is made up of gas particle. We talk about the gas. Okay, the gas is made up of gas particle, number 1. Number 2. Gas can be compressed. A liquid cannot be compressed. Same goes to solid cannot be compressed. Gas can be compressed. Why? Why it can be compressed? What is the characteristic of gas particles? I still remember. We have solid arranged in order arrangement, vibrate in their fixed position. Okay, close, very close. And then we have liquid, further away, molecule of water, and not so close. Randomly arrangement. Okay, and then we have gas. Okay, if you draw for the gas particle, you must draw arrow. Means the movement of the gas are very fast, colliding with each other, as well as the wall of the container. That's for the gas particle. So the movement of this gas particle will give pressure. Okay, the movement of gas particle give force against the wall or the area of the wall of the container, so it will produce pressure. Okay, number 1 is correct. The gas is made up of gas particle. We know that the gas made up of gas particle. Okay, and then number 2. Number 2, which one? Fourth, okay. The fourth one, the gas particle move randomly with high speed, and then when it move, it will collide with each other in the container occur very frequently. Collision occur very frequently. Number three, and the last one is it will produce pressure, give rise to gas pressure. The collision will give rise to gas pressure. Okay. Number one, kinetic theory of matter, kinetic theory of gas. Number two, okay, this one about gas pressure. You have learned this also. Alright, diagram 2 shows a manometer connected to a gas tank. Determine the gas pressure shown. Determine the gas pressure shown. Given to you atmospheric pressure is 76 centimeters of mercury. Manometer. So we have a mercury inside the tube, inside the U tube. So this is the mercury manometer. So how to find the gas pressure that we supply from the gas source here? The gas source supply into the U tube make the mercury rise because of the pressure of the gas make the mercury rise, mercury column rise. And then here we have atmospheric pressure, PATM. ATM stand for atmospheric. So atmospheric pressure already given in the question is 76 cm mercury. Now the question asks, determine the gas pressure shown. The gas pressure that we supply. So the first step, what you need to find out? Nak cari apa dulu? Apa yang tu? You have learned it in pressure in liquid. This diagram also got in 2.1, pressure in liquid. The experiment carried out to find the D. What is D? In the previous experiment, we are looking for D, difference in high. Difference in high. So same goes for this one. Number 2, to find the pressure, first we need to find the difference in high. Difference in high. High of the mercury. This one here and from here. So this is H. H. This H refer to the pressure. Okay. Before the experiment, before we supply the left arm with the gas source, okay, and before the experiment, the level of mercury are same, okay, in both arms, left and right. The level of mercury same. So means here it show that the atmospheric pressure, the high refer to the atmospheric pressure. Okay, 76 cm mercury. Atmospheric pressure to show the atmospheric pressure. Okay, now after we connected with the gas source tank, okay, we supply the gas into the U tube. The mercury column will rise. It will rise. Okay, because the gas pressure, the gas pressure that we supply, the pressure is higher than atmospheric pressure. That's why the mercury column rise. The atmospheric pressure less than gas pressure, or gas pressure more than atmospheric pressure. Gas pressure more than atmospheric pressure. That's why the mercury column rise. So we need to find the H, the difference in high or depth. Okay. So what's the difference here? The difference in height? How many cm? Ashraf, one carry? Yes, 14 cm. Okay, 14 cm. So the difference in height is 40 cm. Okay, now determine the gas pressure. We only know the height. In the second, we determine the gas pressure. How to find the gas pressure? P gas equal to height plus P ATM. Now still remember this one in 2.3. Okay. To find the gas pressure, we need to add with the height. Just add with the height. You already given the atmospheric pressure 76 cm mercury. So height is 14. 14 plus 76 equal to 90. Right. 90 cm centimeters of mercury. That's all. That is the gas pressure. This is the value for the gas pressure. Boleh? Ada soalan nak tanya? Okay, for this one you doesn't need to convert to Pascal. The question didn't ask you. Okay, if the question say that determine the gas pressure shown in Pascal, so then you convert 90 cm mercury into Pascal. Make sure cm convert to meter. How to convert to Pascal? By using P equal to rho g h. To find the unit in Pascal. Convert the centimeters mercury into Pascal. We use this one. But here the question doesn't mention about Pascal, and the question also didn't show the density of the mercury. So no need to convert to Pascal. Just use this equation to find the pressure of the gas H high plus atmospheric pressure in centimeter mercury also. Okay. Atmospheric pressure must be in centimeter mercury because we measure the difference in height. Difference in height here in cm. So the atmospheric pressure also must be in cm. Okay. If the question give you atmospheric pressure in meter, let's say 0.76 meters of mercury, then here you need to change to meter. The height you need to change to meter also. And make sure the unit is same. Okay, so 14 become 0.14. Okay. I still got the same value. You just change the unit cm to meter. Okay. For this pressure, all related with height. Difference in height. Difference in height or depth. Okay, number 3. No question, number 2. Right, we go to number 3. Diagram 3 shows a manometer, mercury manometer also. So what will happen to the mercury column Y if X is connected to a high pressure of gas tank? Okay, X connected to a high pressure gas tank. What happened to the mercury column Y here? What I said just now? What happened if the pressure at X here higher? So what happened to the mercury column at Y? Now give me the answer. What happened? Cepat. Penny Cheng, Simon, The greater the pressure, the greater the height of liquid. Okay, you dah bagi hypothesis. You dah bagi hypothesis dengan conclusion dah. Check. Okay. Yang tu you punya jawapan the greater, increase, decrease tu adalah hypothesis. Okay, soalan just asking what will happen to the mercury column Y. What happened to the mercury column Y if X is connected to a high pressure of gas tank? Mercury column will what? From your hypothesis. The greater the height of liquid. So means that the height will increase. The mercury column of Y will rise or will increase. What will happen? So it will increase. It will increase or rise higher. Rise higher than 20 cm. Higher than 20 cm. We have the same level here before it connected to the gas, and now after connected to the high pressure of gas tank, the mercury column at Y will rise more than 20 cm. It will increase or rise higher than 20 cm. Okay. The higher of the rise of the mercury column, showing that the value of the gas pressure at X. Okay. Number 4. Underline the correct answer. Number 4A. Yang lain bolehlah bagi respon juga. Senyap je ni. Underline the correct answer. The what? Weight or mass of air. Which one? Air on the Earth's surface causes the atmospheric pressure. Which one causes the atmospheric pressure? Weight or mass that cause the atmospheric pressure. You still remember the equation P equal to F over A. So F. So F refer to what? Weight or mass? This one, yes, refer to weight. F also stand for W, stand for weight. F equal to MA. You know that F equal to MA, even there's mass, but the product of MA is the weight. Because we know weight is mg. F can be 2, MA or FG. MA, A acceleration for the motion of vehicles or for object that moving, any object that moving that have acceleration. But G also refer to the acceleration. G also acceleration. Okay, so same. G is also the acceleration. Acceleration due to gravitational. Gravitational pull of the Earth. So same. F and W same. Just to remind that W is stand for weight for mg and F for ma for motion. So here the pressure produced by weight caused by the weight of air, layer of air. This is from the definition of atmospheric pressure. You must remember or understand definition of atmospheric pressure. Okay. B. A mountain terrain has a mountain has a what? Atmospheric pressure. Then at the seaside, because the air of the mountain terrain is what? Yang lain tak nak bagi respon ke? Saya tak marah pun kalau salah. Sunyi je, tak best. Apa jawapannya? Ada higher altitude. Higher altitude. What about pressure? Atmospheric pressure. Lower or higher? And mountain. Okay, good. Chongkawa, lower. We have lower atmospheric pressure at a higher altitude. Okay. Higher altitude, atmospheric pressure is lower compared to the seaside, sea level. Compared to sea level. Okay. Because the air at the mountain terrain is the air at the mountain terrain is thicker or thinner. The answer should be yes, thinner lah. Thinner. Okay, higher altitude, lower pressure. But for the seabed, under the seabed, okay, we increase with the depth. Depth increase. So pressure will increase. This one for under the sea. For the higher altitude, okay, higher altitude, even the high increase, but the atmospheric pressure will decrease because there are thinner air, less air particle at the higher altitude. So the pressure is less, not high pressure. High pressure under the sea, under the sea. Okay, can this one? Right, number 5. It is found that a 14 barometer read 74 cm mercury at the highland, whereas the reading is 76 cm mercury at the seaside. Highland and seaside. So based on the statement, take a correct inference and a correct hypothesis. Okay, the first one, inference. To make inference, you must use the words depends on. MV, RV, responding variable, depends on MV. Or influenced by. Use the word influenced by, affected by, depends on. That is inference in physics. So which one? For number 1, atmospheric pressure influenced by altitude or influenced by the type of barometer? First or second? For number 1, easy question. Activity already. Okay, which one? Good. The first one. Number 5 too. Correct hypothesis. Hypothesis same with conclusion. The one that Mishraf respond just now. The greater, the higher, lower. That is hypothesis. How to write down the hypothesis? Conclusion. Same with the conclusion. Increase or decrease, higher, greater, bigger, smaller. Relationship, we use directly proportional or inversely proportional. That one is for relationship. Okay, now hypothesis number 2. Which one? The higher the altitude from sea level, the lower the atmospheric pressure. Is it correct? Yes, also the first one. Higher altitude, so lower atmospheric pressure. Okay, number 6. 14 barometer X read 74 cm 14 barometer Y read 76 cm mercury. Which of the following statement correctly explain the difference of atmospheric pressure in the term of altitude? Okay, which one is correct? 1, 2, 3, 4. X 74, Y 76. So what is reading show? Ah, cepat. Sangkawa. Is it number 1, 14 barometer X measure the atmospheric pressure at lower altitude? Is it lower altitude or higher altitude? 74 compared to 76? Or Y measure atmospheric pressure at lower altitude? Is it correct? Or Y measure atmospheric pressure at higher altitude? Y 76, X 74. So which one is correct? There are two. Which one? X lower or higher? 74 compared to 76. 1 and 4. 74 compared to 76. 74 is lower than 76. So 74 is measured at higher altitude. Number 2. Understand? See, remember higher altitude. Higher altitude, high pressure is lower. At the seaside, pressure is higher than higher altitude. So number 2 and number 3. 76 cm of mercury is the atmospheric pressure at lower altitude at the seaside. Tempat biasa. Higher altitude, the pressure become lower and lower. Can At higher altitude, pressure become lower. Become lower and lower. So higher altitude we have 74. Lower altitude we have 76. Ni yang betul. Number 2 and number 3. Okay. Any question? Tak faham, tanya terus. Tanya terus. Okay, number 8. List 2 applications of atmospheric pressure. We have so many applications using atmospheric pressure. And the first page for unit 2.3, we have a rubber sucker. Okay, rubber sucker. We have siphon. Okay, the one which relate with the atmospheric pressure, rubber sucker or plunger. Okay, here. This is plunger or rubber sucker. Relate with the gas pressure inside or atmospheric pressure. Comparison between the atmospheric pressure inside and outside. So once you push the rubber sucker down, you push down, the air inside the rubber sucker will move out. So the air here is less. Pressure inside less. Pressure outside means the atmospheric pressure outside the rubber sucker is higher. That's why the rubber sucker stick to the glass, stick to the surface. Because of the atmospheric pressure outside the rubber sucker higher than atmospheric pressure or air inside the rubber sucker. Same goes to the siphon. Siphon we use the high high region to the lower region. Relate with the atmospheric pressure. Higher atmospheric pressure push the water into the siphon. So here lower P, upper here is higher atmospheric pressure. Push the water enter the siphon. Okay, and then we have a vacuum cleaner, drinking straw. Ini semua hot question. Ini PT3 ya. Semua ni PT3 dah ada. Siphon, drinking straw. Okay, drinking straw. When you suck in, ini punya mulut. You suck in. Okay, you suck in the water. Means that the pressure inside the straw is lower. Pressure inside the straw is lower, but the atmospheric pressure is higher. Push the water into the straw. Also, the atmospheric pressure outside the straw is higher. Outside the straw is higher. Push the water enter the straw. Pressure inside the straw lower. So dia punya comparison, vice versa, opposite. Okay, if you make hole, if there's a hole at the straw, then the pressure will be same. So you cannot drink the water because the pressure is same. If there is hole on the straw, kalau ada hole dekat sini, if there's a hole at the straw, so the pressure will be same. You cannot drink the water. Okay. Application of atmospheric pressure. Okay, now another question. 1 hour for discuss question only. Ayo. Okay, this one we have three position of a tube, boiling tube. We fill with a ball of mercury here. Okay, with 3 centimeter high in A, B, and C. The position is different. A is upright, B horizontal, and C we invert the boiling tube. So now, given the atmospheric pressure is 76 centimeter of mercury, because I use centimeter here, so 76 cm of mercury. So what is the pressure? Find or calculate the pressure of the trapped air inside the tube. Find the pressure of air trapped inside the boiling tube. So how to find this one? Okay. For number 1, okay, look carefully at this one. To find the pressure here, okay, the pressure here. Okay, I cross X to pressure X or A. Yeah. Okay. Okay. We want to find the pressure at point A, so we must consider the pressure of mercury also, and then the atmospheric pressure. Okay, so here the pressure here, the pressure at this region of the air trapped inside the boiling tube equal to the atmospheric pressure and the pressure of mercury, the height of the mercury. A combination of atmospheric pressure and mercury pressure. Okay, can you imagine this one? The pressure here, the pressure at point A or anywhere for the gas that trapped here equal to atmospheric pressure and mercury. So you just add 76 cm mercury plus 3. 3 cm. 3 cm of mercury, because we use mercury, so 3 cm mercury, the pressure for the mercury. So 76 plus 3 equal to 79 cm of mercury. Right, B. This one can, for A. Okay, for B, find the air trap at B. Air trapped at B. So this one, we consider that P at B, a pressure at region here equal to atmospheric pressure. Okay, there's no other force acting on the mercury rather than this one. We have the weight of mercury, so that's why we add this one. The pressure is same. Pressure same. We place it horizontal, so the pressure is same. So B, pressure at B equal to atmospheric pressure which is 76 cm of mercury. Okay, alright. Bangun dah anak saya. Okay, for C, pressure at C. So pressure at C. Okay. Wait. Alright, pressure at C. Okay, pressure at C equal to atmospheric pressure. We must minus with the mercury. We must minus with the mercury. P atmospheric pressure minus 3. Minus 3 cm. Minus the weight. We refer to the weight because there are weight act on the mercury. 3 cm. So we need to minus. We need to minus. Okay. Actually, for C, pressure at C combined with mercury. Combined with the mercury. The high for mercury, Hg, equal to atmospheric pressure. Now to find the pressure at C only, we need to minus PATM, atmospheric pressure, minus high of the mercury, which is 3. So 76 minus 3 equal to 73. 76 minus 3, 73 cm of mercury. Okay. Boleh tak yang ni? Another question for number 9. Yeah. So you just remember for horizontal, pressure is same. Either for the gas or atmospheric pressure, same. The gas trap here, same with atmospheric pressure that act on the mercury. And then upright, you just minus. Minus because the pressure here combine. Combine. Atmospheric pressure and mercury pressure is combined. Okay, this one minus. Atmospheric pressure minus with mercury to find the pressure of gas that trap up here. So remember that one. Okay. Ni nak masuk 2.4. Okay. Pascal principle. Can we continue? Or you have any question about 2.3? Any question about 2.3? Ada soalan nak tanya yang tak faham? Tak ada Ni apa? 10 orang je dekat sini ni. Ten out of 30. Okay, Pascal principle. Pascal principle we relate with the pressure in fluid. Pressure in fluid. Fluid refer to liquid and gas. Liquid and gas. So for Pascal principle, apply the principle of transmission of pressure. Principle of transmission of pressure in a closed fluid. If you see the coconut extractor here, we give the pressure against the area of the coconut. So force against area will produce pressure. When there is pressure, the coconut milk can be compressed. The pressure transmit to the coconut milk and produce grated coconut. Okay. We look at this activity. Activity 2.6. Okay, we have a piston, Pascal's piston and plastic basin. Basin is down here lah. Okay. Alright. And then this piston got hole surround it. Got hole. Okay, once we give a force, against the surface area of water. Okay, surface area of water, the pressure will be produced. It will produce pressure. So the pressure will be transmitted throughout the water or throughout the liquid. Okay. When the pressure is transmitted throughout the liquid, okay, the water will come out with the same force or same pressure. So it will have the water will come out in all direction. Because the pressure is transmitted uniformly or equally throughout the liquid. That's why the water come out from all direction. Not at the left side only, not at the right side only. The water will come out from all direction. Means that the pressure is transmitted throughout the liquid. That is Pascal principle. Itu sahaja. Okay, we look here. When the piston is pushed, a force is exerted on the surface of water and pressure is produced. So the pressure inside the water is transmitted uniformly or equally throughout the water in all directions. Okay. This causes the water to spurt out from every hole. Okay, now, for the definition for Pascal principle, okay, it states that the pressure applied to an enclosed fluid is transmitted uniformly or equally in all directions in the fluid. Instead, the pressure applied to an enclosed fluid or enclosed system is transmitted uniformly or equally in all directions in the fluid. Okay. Boleh faham tak? Pascal principle. Transmission of pressure in liquid. Transmission of pressure in liquid. Okay. Now, we apply the Pascal principle in hydraulic system. A hydraulic system. Okay, hydraulic system consists of liquid. The system that consists of liquid. We give a pressure to one side of the system, of the hydraulic system, and we will observe what happened to the another side. Okay. According to Pascal principle, pressure applied on the surface is transmitted uniformly throughout the liquid. If this pressure is transmitted to a larger surface area, okay, what is the effect on the force produced on that surface? Okay, the question refers to the activity here, activity 2.7 here. If we give a small force here, we give a small force, okay, against the surface area of the water, inside the syringe, inside the small syringe. Okay, we give the force against the area of the water inside the syringe. So pressure is produced throughout the liquid. Okay, pressure is produced and transmitted throughout the liquid here, and give another output force, the second force for the bigger area here, A2. This one F1, A1, produce pressure. So the same pressure that produced at the first system, okay, will give the same pressure at the second system, P2. Okay, with a bigger area. And what happened to the force? What happened to the force that produced here? We give a small force, okay, and then pressure is produced. Okay, the same pressure will exert a larger force. Will give produce a larger force here, because the area is bigger. Area for A2 is bigger and will produce a bigger force also. Okay, so that's why here state that hydraulic system. Okay, hydraulic system. This is hydraulic system. Now we use two different size of syringe with different surface area. This hydraulic system will act as a force multiplier. Even we give a small force here, it will multiply the second force, or the output force. Here, small force, at the small piston will give a double force at the second piston. Okay, that's why we call it as a force multiplier. A force multiplier. The force, the output force will be bigger, because F equal to P times A, pressure times surface area. Okay, pressure times surface area. If the surface area bigger, so the force, the output force also bigger. Understand? The output force also bigger. If even we use the same pressure, we use the same pressure. Understand? Right. Yeah. In this activity, the mass on the small piston, we use 50 gram. 50 gram. We use the mass. Mass. But we need to understand, we can convert this mass into weight by time with 10, right? Okay. 50 gram convert into Newton of force. How much the value? 50 gram turn to Newton. How many Newton? One carry? One carol? Ah, how many Newton? Gram to Newton. 500 Newton? No. Look carefully the unit used. not 500. You must convert gram to kilogram first. So this one must divide by 1000. 0. You will get 0.005. 1, 2, 3. 1, 2, 3. 0.05. Okay, 0.05 kilogram. Then in Newton, you will get 0.5 Newton. 0.5 Newton. So here we provide with 0.5 Newton. Okay. With the given surface area of the water or diameter of the piston, okay, we get the pressure. Okay, so the same pressure will be produced here. Okay, will be produced here with the higher surface area. Then the output force also will be increased. Will be higher. Will be double. So for total mass on the large piston, this large piston will lift double mass. So means 100 gram or equal to 1 Newton. Okay, it will be double. Multiply double. Okay, can we double the total mass on the large piston. We consider that the area of A2 double. Okay, so for 80 gram will be 1600 gram or 1.6 Newton. Okay, I use force because I want to relate with the uh, P equal to F over A. That's why I use force. Okay. Kalau eksperimen kita guna gram lah. We use gram first and then we convert to Newton. Convert to force. Right. Okay, masa dah habis. So we stop until here. Okay, until activity 2.7. Right. Then next week, Thursday. Thursday we finish this unit. Actually, Pascal easy. You just use the equation F over A. F over A only. Okay, we'll discuss later. Right. 9